So the next definition to alter for digraphs is your degree of your vertices. So previously your degree of your vertex was just the number of edges that it connects to, and that is kind of similar but not entirely the same, because now you're going to have, well, first you had this situation. Let's first do the previous situation. So you had the degree of A, in this case, was equal to 2. Now you have a digraph, and the digraph has directions to it, right? So you have, let's do it like this to show you the major difference. Now you're going to have that the degree of A, and you sit there and you go, well, one of them is going out and one of them is going in. So it actually is going to be broken into two components, where you're going to have the out degree, which is going to be denoted by your degree positive V, and then you're going to have your in degree, which is your degree minus V. So the out degree is the number of arcs radiating out from the vertex. So in this case, it'll be A as the vertex, because we are looking at A in this case. So we're going to have, in this case, we have the out degree, and let's just keep them color-coded. We have one arc radiating outwards. So the out degree of A is going to be 1, and here we have one arc radiating inwards, so the in degree of A is going to be 1. Okay, so the in degree is the number of arcs going into the vertex V, and the out degree is the number of arcs radiating out to the vertex V. So let's write that as a formal definition. Let D be a digraph, and V be an element of the vertices set of the digraph. The out degree of V, denoted degree positive V, is the number of arcs, and that is very badly written, of arcs radiating out from V, and the in degree is the number of arcs radiating into the vertex V. So let's just do another example. Okay, so we're going to do another example. So let's just go with A, B, C. Okay, that's not how I'm drawing the nodes, so let's just be careful there. C and D. So I have that, I have that, that, that. Okay, so there is my digraph. So my degree plus of A, and then I'm going to have my degree minus of A, then I'm going to have my degree plus of B, my degree minus of B, degree plus of B, degree minus of B, degree, oh, be useful if I actually change the vertex, C, D, degree minus of D. Okay, and just remember your plus is the number of arcs radiating out of the vertex. So if we look at A, do we have any arcs radiating out? We have this one over here, so that's 1. How many arcs are radiating in? We have this one here, and we have this one here, so it's 2. Then we go ahead and look at B. So the arcs radiating out of B are 1. The arcs radiating into B, ooh, I made a mistake, didn't I? Arcs radiating out of B, we have this one here, and we have this one here, so this is actually 2. Radiating out of B is 0. Now, how can I easily see if I made a mistake kind of situation? Well, I can look at the traditional concept of, say this wasn't a digraph, and then I look at A. The degree of A would have been 3, right? So my in and out degrees should, add up to 3. And my in and out degrees here, because the original degree of B, if it wasn't a digraph, was 2, it should add up to 2. So that's just a nice quick way to check. Okay, now our degree of C, arcs radiating out of C is 1. Arcs radiating into C is 2. Arcs radiating out of D is 1. Arcs radiating into D is 1. Okay, so again, you can check by looking at if it wasn't a digraph, what is this degrees? It should, add up together. Okay, so one of the other aspects at play is now that we have the in and out degrees, how does it relate to size? Because remember previously we had that the sum of the degrees of normal graph's vertices was equal to 2 times the size. Now we're like, we've just worked out that the size of a graph is n minus 1 without the divide by 2. So does the 2 actually exist there, and what's going on? So now when we think about this, let's actually just look at this one for an example. And we say, okay, what is the size of this graph? So the size of G is equal to 1, 2, 3, 4, 5. 5, right? Now, what we can do is we can be, okay, let's add up all the vertex degrees going outwards. So if we go ahead and do that, we have 1 plus 2, that's 3, 4, 5. I'm like, that's convenient. Okay, so we have that the sum of the degrees going outwards, VI for I is equal to 5. What about the sum of degrees going inwards? So we look there, and let's just use a different color. We have 2, we have 0, we have 2, and we have 1. So we have that the sum of the degrees of VI is equal to 5. And this is going to lead us to a theorem, the first theorem of digraphs.